Hello everyone, myself Mohammed Akar. So today's topic is object code and object program generation for SIXC mission. Lesson 1BE 20CS087. Subject System Software and Components. Subject code 18CS61. So let's get started with the program. So the given data is XOR statement, given opcode and operand. So we will get this table. And first, we need to generate the object code from the following SIC source program and also write the object code program, that is to write head record, X record, and head record. This is another part of the given data in which we have some instructions and with the respective opcodes in hexadecimal. So now let's get started with our program. First, we need to generate location counter and followed by SIC source program. The location counters can be given as 14 types, and this SIC machine has mainly 4 types. Type 1, which are equal to 1 byte, type 2, which is equal to 2 bytes, type 3, which is equal to 3 bytes, and type 4 is equal to 4 bytes. These are also called as 4 formats. In type 1 format, we have only opcode with 8 bytes. In type 2 format, we have opcode and 2 registers R1 and R2, respectively. We will see in the PPT. So the starting address, location counter, and the operand value will be same. So as you can see, the operand 3000 is equal to location counter in line 2 equal to 3000. So now let's calculate all the location counters for all 14 lines. So in the second line, we have X as a register. So we add hexadecimal value to 3000. So we'll get 3002 byte. And in the third line, we have hashtag 0 and LDA. LDA refers to instruction which has 3 bytes. So we'll add 3 and we will get 3005. And fourth, we have plus LDB, which refers to type 4. So we'll add 305 with plus 4 in hexadecimal, and we will get 309. The base in the fifth line, the base doesn't have any location counter, so we'll skip that. And in the sixth line, we have add, which is also a type 3, so we'll add 3 hexadecimal value to 309, we'll get 3003. And in seventh line, 300C also has TIX, which is also type 3, so we'll add 3 to 300C, which will result to 300F. And in the 8th line, we have JLT, which is also same, so we'll add 3 bytes. And in 9th line, STI, which is also same, which is also a part of type 3, so we'll add 3 bytes. The 10th line, RSub, which is also same, so we'll add 3 bytes to 3012, which will result 3015. And in 11th line, RESW, which is a reserve word, so we'll multiply 3 into 1 for the operand value, and we'll add that to location counter 3018, which will result to 301B. So in the 12th line, we have operand reserve bytes 2000, which we need to multiply by 3, which will get 6000 bytes, which converted into hexadecimal gives us 1770 bytes, which will add to 301B, which result is equal to 478B. On the 30th line, 471B, we have reserve word 1. So 1 word is equal to 3 bytes. So we'll add 3 to 478B, which results to 478B. So the first part of the program, finding of location counter, is done. Now let's move on to the second part. So now let's get started by finding object code for each of the lines. So as we can see in the first line, we have operand X, which is of type 2 or format 2. So in format 2, we have opcode, which is of 8 bytes, R1 and R2, each are of 4 bytes. So in opcode, we have clear as given in the above tables is equal to P4. By converting P4 into decimal values, we will get 10110100, which will be done in opcode. As we know from the register table, x equal to x value is equal to 1, so we'll put 001 in R1 and leave R2 as it is 000. Now we will divide the full format 2 into 4 decimals, which we can convert it into hexadecimal, which results 0111011 is equal to B, 0100 into 4, 001 into 1, 000 into 0. We will write this into the first line of the respective object code. Now let's move on to the next one. Here, as we can see, we have LDA, which is format 3, and the value of LDA is equal to 00 in hexadecimal. We will convert it into binary format, which is equal to 8 zeros. When in operand we have hashtag 0, which refers to immediate addressing mode. So we'll put immediate as 1 and indirect addressing mode as 0. If indirect is equal to 1, then immediate will be 0. So in this condition, immediate is equal to 1 and n will be 0. And x is also 0 as we don't have any index. P and P are also 0. P refers to if it is format 3, it will be 0. If it's format 4, it will be 1. And in format 3, we have 12 displacement value, which holds 12 binary digits, which is the address of which is also 0. Now we'll convert all the given code into object code, which is equal to 000 equal to 0, 0001 equal to 1, and all are also again 0. Now which will be written in the opcode, which is equal to 01, 4 times zeros. Now let's move on to the next location counter, which is plus LDB. Plus LDB, as it has plus in front of LDB, so it's format 4. LDB value is 68 converted into binary format, which is 011010, and LDB has operand total which starts with hashtag. So we'll put immediate value as 1 and n equals 0. We don't have any index, so 0. Base and the program counter are also 0. So as we know, format 4 we are using, so A equal to 1. In format 4, we have 20 byte address, which is given by the total operands location, which can be found out by the operands location, which is 478B, which is converted into binary number 000, 0100, 0111, 1000, 1011. By writing all this, we can get the object code by clubbing four binary numbers from the first. It is given as 6910478B. Now let's move on to next location counter. For base, it is a assembly directive, so we don't need to calculate the object code as it doesn't have any location counter also. So now let's move on to the next one. So in the location counter number 30999, we have label as loop and opcode as add, so it's format 3, and add value in hexadecimal is 18, so we'll convert it into binary number, which is 001100006. As opcode has only 6 bytes of space, so we'll take starting 6 bytes, which has 001 and 10. So as it contains x in the operand, so we'll put x value as 1, and if the value of x is 1, then immediate and indirect will also will be 1. So now we need to calculate the base, if it is base or program counter, which can be done by uh, displacement formula, which is equal to the target counter minus the next program address, which is equal to 301B for the table value and minus the next program counter, which holds the address of the next instruction, which is equal to 300C. By subtracting this, we'll get 00000F, which is in decimal equal to 4 times 1, which is in the range minus 2048 to 2047. So we'll write the value in the address, and now we'll write the object code for converting the given binary numbers into the hexadecimal format, which is equal to 1BA00F, which will be written in the respective object codes. We'll go to the next one. And in this, we have TIX, which is format 3. The TIX hexadecimal value is 2C, which will be written in binary 0010110. So we'll take the first 6 bits, which is 0010111. As we know, count is not indirect or not immediate addressing mode, and it doesn't even have x value, x in it. So we'll put n and I 1. So now we need to calculate DNP. So the displacement, as we know, the formula is the displacement, the counts target address is 3018 minus the next program counter value, which is held by the program counter, is 300F, is equal to, we'll get 0000009, which is in decimal value is equal to 1001. So it falls in the range of minus 2048 to 2047. So we'll write it as it is in the binary format in the 20-bit address. So the object code of this line is given by clubbing one starting four decimals into one hexadecimal, which is given as 2F2009. So now let's move on to the next one. In this, we have JLT, which is also format 4. The JLT hexadecimal value is 38 converted to 0011 and 1000. We write the first 6 bits. And in JLT, as we have loop, which is of the does not belong to immediate nor index addressing mode. So we'll write n equal to 1, I equal to 1. It doesn't have index, so we'll write x equal to 0. Now we'll calculate the displacement, which is equal to target address. The loop's target address is 3009 minus the program counter address, which is the next address, which is equal to 3012. So minus will get minus 9, and we'll convert it into hexadecimal, which is FF7, which binary value will write down in 12-bit displacement address. Now we'll write the object code by taking first 4 binary numbers and converting it into hexadecimal value, which is equal to 32FF7. Now let's go to the next one. In this STA, it is of format 3, which has 0C as its opcode. The opcode is written in the binary value, which is 0001100. We will take first 6 bytes as the opcode has only 6 bytes of space, as total is not in the form of indirect or not immediate or to more, we'll put n equal to 1, n equal to 1, and x is not in the operand, so we'll write x equal to 0. Now we'll calculate the displacement. The displacement is equal to the target address, which is 478B for the total, which is given in the table, minus the next program counter address, which is 3015. We'll get 1776, which converted into binary number is not in the program relative, minus 2047 to 2047. So we need to calculate another formula, which is displacement is equal to target address minus the base address. So 478B minus 478B, which is the base address for the total. So we'll get 0, which falls in the range of 0 to 4049. The object code will again return as 0f4000. So now let's move on to the next one. We'll find out the opcode for rsub. The rsub is given as rsub's opcode is given as 4C, which in binary is written as 0100. 1100. We'll take first 6 bytes, which are 010011. As it doesn't contain anything in the operand, we'll put n equal to 1, I equal to 1, x equal to 0, base equal to 0, p equal to 0. As it is format 3, input e equal to 0. Now the displacement is also 12 bytes of zeros. Now we'll calculate the object code by clubbing first 4 binary numbers to hexadecimal value, which is given as 4F0000. Now moving on to the next one, RESW. RESW, we don't calculate the object code, and similar to all the three RESWs in the table, for the end assembly directive, we don't have to calculate the object code, but we can write the starting location counter address as its object code. Now after calculating all the object codes, we need to convert the object codes to object program, that is divided into header, text, and end record fields. First, let's start with the header record, which starts with H, which represents header, and a caret symbol, and with 6 bytes of spaces, which represents the program name, which is given in the label. It is sum, and 3 spaces left, as we occupy only 3 spaces for the name sum, and then it is followed by a caret and the starting address, which is also of 6 spaces, but we only need 3, so we will write 3000, and again with the caret, and the last part of the header record is given as the length, which will be calculated by the largest location counter value minus the starting location counter value, which is 4780 minus 3000, which is equal to 178p. Now we'll write the text record, which starts with T and a caret with 6 bytes of space, with starting address 00300, and by separating all the opcode values, we'll write the opcode values, leaving the first 18 value, which will be explained after, which can be calculated after writing all the object code values. After calculating all the object code values, we'll count the total bytes taken by the opcodes, all the opcodes, which starts from B410 and ends with the 4F000. By adding all the bytes, we'll have 14 columns, and each 2 columns equal to 1 byte, so we'll get 24 bytes. So converting 24 value into hexadecimal, which is 18, which we'll write after the starting address. So the last one is the end record, It starts with E and a caret, and it has 6 bytes of space, which also includes starting address. So as we know, starting address has only 4 bytes. We'll include 00 in the starting. So this is the end of the program. Thanks for watching.